Thank you very much for inviting me to give a talk today. And as I wrote this talk over the last week, actually on and off, I completely redid entire sections of it and deleted them. So if you want me to expand on any part of it, please let me know and I'll go ahead and do that. But I thought eventually I settled on basically telling a kind of personal journey for the most part. In how I got into doing these animations for outreach. And so I've basically shortened the title to Animated Science Communication. And hopefully this video works. This is just an example. It might be a bit jumpy and laggy because of Zoom. It looks okay on my screen, but there's a YouTube link down there, and there should be one appearing in the chat. Excuse me, in the chat if you wanted to see that. Thanks. And yeah, so this is basically a comparison between the sizes of the planets and the moon and Pluto. I'm not going to debate anything about Pluto today. And then you see the sun at the end. And so this is basically just a simple comparison video. After I made this about a month ago, it was seen by about 1.7 million people. Which is, I still think is ridiculous because it's such a simple thing. But these kind of things, they go viral. And so it seems like a really good way of doing science communication. And I'll talk about my personal background next. So I got my PhD at the University of Leicester in 2010 to 2014. Then I went on to do postdoc work at Boston University. And I had a fellowship after that at NASA Goddard Space Flight Center over in Maryland in the US. And then came to JAXA in last year, and that's where I've been since, especially lately, completely fixed here. But yeah, my general research is that I use telescopes on the ground, usually in Hawaii, to look at Jupiter, Saturn, mostly Jupiter and Saturn, but also Uranus, and in future I'll be looking at exoplanets as well. The topics that I publish on are usually about the upper atmospheres of Jupiter and Saturn and the auroras, which you can see here in these images. This is the ultraviolet aurora, and basically they're produced by an interaction between the planet and its near space environment. So that's kind of what I focus on, is how planets interact with their local environments. That's led me to go on to do stuff to do with Saturn's rings, which I'll talk about in more detail. Saturn's rings interact with the planet in the atmosphere, and I'll talk about that. And also Jupiter's Great Red Spot a couple of years back. So my science communication story, I guess, even though I've been doing science since 2010, at first I was doing lots of, the usual kind of giving talks at schools and stuff like that. And then, I actually used to make posts on Twitter for years, like again and again and again, talking about some kind of science fact. I was trying to do maybe a big section of facts every Sunday or something like that. And nobody was sharing them anywhere, and I thought, okay, so I gave up, essentially. But this is just some statistics in the last couple of years, and what animations or learning how to do simple animations has done for my science communication. So far, there's been at least 150 million views all over different platforms. And from that, actually, usually I post on Twitter, and then sometimes they go viral, and then there are lots of media people on Twitter, journalists and so on, and they see the animations, they see the reaction, and then they end up writing a news article. So it's kind of, these news articles come out, and sometimes I get a message from someone saying, oh, I just saw you here, and it's kind of fun. Overall, I'm getting about 10 million Twitter engagements a month, and the followers have gone up a lot. And one invitation to speak about science communication strategy, that's today. And so really what I tell people a lot is that in terms of their effort, that I'm putting into it. At first, it was quite a lot of effort, but integrated over a couple of years, it's been really kind of about 5 hours a week on average. And really, some weeks I'm doing 0 hours, and some I'm doing up to 20 or something. But for the most part, the biggest time consumer is making the animations themselves, and they can take sometimes they can take just a couple of hours, or sometimes 20 hours or so. And so if they get seen by millions of people, then I see that as kind of a very efficient strategy in terms of my hours per number of views. And I'll talk a little bit more about that. Yeah, so I'll briefly explain what happened for me and how this all happened. But the one big caveat is that I am talking about the solar system, which is a pretty cool topic. And I studied Saturn's rings and the Great Red Spot and the aurora, and I am very lucky to be studying these things because they're just really cool, in my opinion. So this is how it happened. So at the end of 2018, I was leading a paper talking about Saturn's rings, and our research showed that the rings of Saturn were leaving an imprint on the planet. And I'll just quickly play that. This is just a simple animation showing the magnetic field lines around Saturn and how they're connected to the planet. It turns out that lots of water, literally water, is streaming down these magnetic field lines and going into the planet at a rate of maybe up to tens of thousands of kilograms per second. And if you actually do the math, that would mean that the rings of Saturn wouldn't even be there in about 300 million years. And so this was a big press release we had 2018. Before we got around to doing it, we wanted to make a graphic like the one you're seeing here. This was actually made by NASA Goddard. But maybe you're familiar with how when you want a graphic made for a press release, you better be asking months in advance, and you're kind of competing with other people. There's not a lot of freedom about that, and I think 50% of the time we've been refused any kind of animation or graphic department help in our press releases. So that's just a background thing to keep in mind.
James, sorry.
Yeah.
We see a rectangle on the right-hand side of your slide. So maybe we were thinking it could be, yeah.
Okay, that's,
yeah.
Okay, I'll move it over there.
Yeah, thanks very much. Thank
Okay.
you. Sorry for the interruption.
No problem. Yeah, I thought I was the only one seeing that, so thanks for telling me how to get rid of it. I would have left it there the whole talk. Yeah, yeah, we had them make an animation, and they had a cool voiceover and everything like that. And so this is only one part of a larger animation. But one thing that was missing, while I'm showing the mechanism here, I'm not showing what the rings of Saturn would look like in the future. And let's see if I can. Okay. Yeah, so I put some dates here so I remember them myself. But yeah, it was Friday afternoon, the Monday before the press release came out. And I thought, wow, yeah, we've got this press release showing how the rings of Saturn are going to disappear in the future, or at least the mechanism of it. But we hadn't made any image showing what they'll look like in the future. And so I just realized this GIF is automatically running. So it's kind of spoiled my little surprise. But yeah, this is what they would look like in the future. This is an image I made using Illustrator and Photoshop. All I did was remove the rings in one image and then basically use an online tool actually called easygif.com. It's a website you can just go to, and if you have two different images, you can make one transition to the other really, really quickly. In fact, even though I know all these other tools, I actually still use this website because it's just so much more convenient and it's very fast. And so this probably took me way too long, maybe 5 hours or something ridiculous to do that. And I thought, wow, that's all right. Actually, that shows what the rings would look like. And that was really important to me because this work, this would have been a frequently asked question. I've been down this road before. people ask, oh, so what would they look like in the future? And I thought, well, this would really help if I showed it. But I didn't really stop there. I ended up, I had maybe another day and a half, and I thought, well, I already paid for Adobe Creative Cloud. This isn't one giant advert for it, but I will be mentioning it a lot. Adobe Creative Cloud includes things like Acrobat Reader and Photoshop and Illustrator. And so those are the things that I always used, and I already paid for that. But there was a whole suite of other programs that they have, which I had not even I'd not even heard of before. So I thought, well, let's just play around in those. So I tried a few programs, and then I ended up using Adobe After Effects. And then so I just quickly made this animation here, which shows, it could be better, but it just shows the Saturn system and the rings disappearing over time. Basically just a simple thing like that. And then on Sunday afternoon, I had sent that to NASA Goddard people, and they got it on Monday morning. The press release was at 10 a.m. So they received it, and they managed to just about squeeze it onto the press release pages. Sorry, there's a car or something. And then, funnily enough, it ended up being something that the New York Times used just a few hours later as part of the top part of the article. So this is actually just a screenshot. This is actually a video that they put on. And I thought, wow, that's kind of ridiculous. I'd never made an animation before, and then within basically a day, it was on New York Times, and that gave me a lot of confidence, actually. And I felt a lot of freedom from that, because it takes months to get this kind of stuff done if you want, and there's a lot of back and forth and so on. And so maybe a few weeks later, I had some time during the holidays, so I made this. So this is near just after Christmas, actually, and so I just realized that there wasn't any animation out there showing all of the planets rotating at their relative rates, tilted in their correct directions and everything like that. And I thought, I'll just quickly make that just for fun. And then, so I posted that, and it went crazy viral. And I thought that was ridiculous. But it does speak to something missing, I think. When I was Googling, I maybe spent 2 or 3 hours looking around, trawling through the internet to try and find if anyone had done this before. And they have, but it was kind of like a 1990s GIF version. So yeah, I always think that there's a huge niche for making these kind of things. And, this is one way of looking at it. If it took 16 hours to make, that's 1 hour of effort per 100,000 views. And so that's kind of how I like to spin it, in a way, so to speak. There's actually a mistake in this animation too, which is kind of funny. I put the wrong day length here. It should be 243. But luckily Twitter told me within about an hour or something like that. So I reposted a new corrected version. So that's another benefit, actually. Also, I missed out Saturn in this giant, really big hashtag. So, mistakes. So anyway, during or just after that, the US government shut down for 35 days, the longest shutdown ever for the US government. I think the one after that was 21 days. We were unfortunately not allowed to come into work, but we were still paid, which is, such a shame. And we weren't allowed to check our emails or do anything like that. So I pretty much could only do one thing, and I just started to make a bunch of Lightspeed animations. This will be interesting to see how this comes out, but because of, it's okay, actually. So my stuff is very sensitive to the frame rate. Twitter allows a 60 frames per second frame rate. I'll just start this from the beginning. This is the speed of light visualized going around the Earth. I actually made this one purely as a joke. I thought, I actually had it on my computer for a couple of weeks before I even bothered sharing it. I didn't think it would I thought it was kind of useless because it was going so fast, but at least you can see it, and you can freeze frame and see it too. So yeah, 7.5 times a second it goes around the Earth, and then we have it going to the Moon, and it takes 1.255 seconds on average to get to the Moon. And then we have it going to Mars. So this is the real-time speed of light. So that's one big thing to say. This is all real time. Yeah, this is, then we go from the sun to Earth. Usually the most commonly quoted thing you'll see is, oh, it takes 8 minutes for the sunlight to get to Earth. Yeah, I actually have this going for a long time, so I won't show you all of that. But if you're interested in it, on my YouTube channel, I have the sun to Pluto in real time, and it's 5.5 hours long. So if you're, if you want a nice Friday night in sometime with a few beers, you could just watch that all day, all evening. Let's see. So now after that, since it was going well, I ended up making a lot more videos over the last couple of years. Some of them took an enormous amount of time. Usually the more time I spent on one, the less views it would get. It seems to be the trend. I don't know why. Some of them are actually existing videos. Well, one or two of them are that people like NASA have made that I've remade in a different way, or upgraded it from really bad resolution to good resolution or something like that. Because people can now see things in better resolution. And so let's see. Yeah, so what normally happens actually is I make one video and then people say, oh, what about this? So if I make a video showing the speed of light going around the Earth, they might ask another question about how it would look if it goes to Mars, and so on. And so a lot of these videos, maybe over half of them, are original ideas that I've got in my head, and the other half are from frequently asked questions. Kind of, you answer one question, and then you have another 10 questions, the usual science thing. And so it's not just about Twitter or YouTube or whatever, but these things are being used outside of social media a lot. And so I've just got some examples here. Last year I asked people where they're using it, and basically it's every level of school, all the way up to university, and including Stanford University. And I thought that was, for the universities like Stanford, I know they have a lot of money, and so I was actually thinking, I know they're selling, they have a lot of money going into tuition fees, and they're using my free animations, and I thought, maybe I could go into business or something. But now all of my animations are completely free. It's easier that way, and on my YouTube channel there's no adverts, and I don't put any, except for one or two videos, there is no music on them either. If you add music to your YouTube videos, you tend to have to pay some kind of royalty, and it's too much effort, so I don't bother. And on Twitter, 70% of people are on a mobile phone or mobile device, and if they are listening to anything, it's probably their own music, so I don't want to interrupt that. And also the places like National Air and Space Museum and planetariums are using them, and people that I know at NASA, JAXA, and NOAA were using them. This is the I can't remember the it's the North American Oceanic. I'm not very good with acronyms, but yeah, they put some of my videos on a sphere, so different planets. They cast it to a physical sphere when they go to do public outreach events, and of course conferences. And so these are some messages from people all over the world. And actually, this is, I probably would have calmed it down or stopped if not for receiving messages like this. It just makes you want to carry on. It's really quite heartwarming. And there's a lot of messages from people who are saying that they're showing it to their children and stuff like that. Let's see. So one of the things about about these animations. I'm going to get a little bit philosophical for the second half of this, I guess. I've never really talked about this kind of stuff before, so you can definitely probe any of this or talk further in questions. But typically you have a fact, right? So Jupiter is 1,300 times larger than Earth by volume. You can fit 1,300 more Earths into Jupiter, and even though it's so big, it spins 2.4 times faster than Earth. You could tell someone that's interested in science that fact, and they'll be happy about it. Maybe they've heard it before, but if not, they might be a little bit mind blown by those numbers. But for the most part, I don't know if you speak to the same people I do throughout my entire life, but I think over 50% of the time, if I'm talking to people like my friends and I tell them some science fact, they kind of just go, so what? Or they don't really, they could be polite and say, oh, cool. Then they'll change the subject straight away. And I think, they didn't really feel what I felt about that fact. It doesn't have to be a cold, hard fact. And so I do ask, what is the exact reason that I find that fact astonishing? And it is because I'm picturing that in my head, and I understand the kind of momentum of in this case Jupiter, the momentum spinning around. It's so huge and big and everything like that, and it's really there. It's not an abstract thing. We can talk about space stuff or microscopic stuff, and I think there's a tendency for us to think of them as very abstract, like they don't really exist. But so that's something I want to target with realistic animations. I want to actually show what it would look like if you were there as much as I can. And so I do feel that if someone that wasn't generally interested in science or not enthusiastic about science, if they could actually see it, they would be as interested. And also put a little aside here. Everyone feels happy when they've learned something, and these are kind of just opinions. This is probably, it's got to be rooted in fact, I'm sure. But we do feel joy from learning, and I have to believe that that's to do with understanding your environment. If there's any biologists here, please tell me off if I've got that wrong. But it does seem to tally with why we explore in the first place. And so what I think animations do is they kind of skip past a lot of having to explain things, because you've probably been mid-explanation and you see someone is kind of maybe even yawning under their breath about what you're talking about. And so I think that if you can skip past something and just show them something dynamic, they'll see what you see in a quicker way. Images are also great. But I think animations have a particular strength because they give you this sense of temporal behavior. They show you how something is moving with time. And so, I think that's one of the biggest strengths of animations versus images, is that they're giving you a sense of time. You can also zoom in and out and make something look bigger and smaller, which is kind of a spatial context that animations give that the images perhaps don't. I do think that technology is just about right now for animations. You probably, a picture is worth 1,000 words is the usual saying, but a video can actually contain up to 60 frames a second that you can see. So I think, if you do the maths, there's a lot of words. But I feel like there is nothing better for conveying information density, getting that information in someone's head before they lost interest than some kind of video, which I guess is why YouTubers' videos are so successful. They have kind of everything going on at the same time. And I think, internet speeds on mobile devices just become good enough across the board. I think most people now have some device where they can see in HD or very similar to it. And also, apps like Twitter and everything, they support that. I'm a much bigger fan of Twitter for this stuff than Instagram. Actually, I deleted my fairly big Instagram account because I just couldn't keep up with if you do a kind of a landscape picture or video on there, they just destroy the resolution, and it was bothering me too much to keep that running. But yeah, so I kind of stick to Twitter for the science stuff. I also just much prefer it. It's got a lot better feedback. You can have replies from people properly, and you can have thread discussions and everything like that. Yeah, so I think that being able to see these things, a diagram in detail, has only just become possible, actually, maybe in the last few years. And so now is the time to strike by making animations. But let's see. Yeah, so more kind of philosophy on this topic. I really deeply think that the science audience that exists in the world is too small relative to how much science is doing. Given that pretty much everything that we're using right now and day to day is based off science, it seems like it seems unusual that it's never really one of the top 30 trending things or whatever. And it does seem to be a smaller part of society, except for when we're talking about we're in a pandemic right now, so of course that's going to be unfortunately we're fighting a lot of denial about things like that and climate. So when science does come up in conversation, unfortunately, that's what we get. It would be nice if there was more interest in science more generally, though. So I just quickly Googled earlier. There's a science report. I was trying to figure out how many scientists there actually are in the world per number of people. And UNESCO science report said that in 2013, there was one researcher per 1,000 people. I don't know exactly what the definitions were for that, but I know that in astronomy, we normally quote that there is about 10,000 active researchers, which is pretty much one astronomer per million people, which seems kind of ridiculous to cover the entire universe, just to have one person to do that. But of course, all these people that you're seeing, they're obviously very busy. We're all doing science, and we're all doing things like teaching duties and everything like that. And so outreach is there too. But so I think that kind of a way of revolutionizing that would be to do more videos and stuff like that. But it is a kind of a different skill set. But if you can do 10 hours of work and reach 100,000 people, I'm just saying that the efficiency is high. You can reach 10,000 people for 1 hour of work. That seems pretty good. I say 10 hours because sometimes if I do maybe an hour-long public outreach talk, it probably does take me about 10 hours on and off of work to produce that if it's kind of an original document, if it's a public outreach talk I've done before, then there's a lot of copy and pasting and it could be less. But I feel like it's a very efficient way of reaching all the taxpayers that fund our science. And there's definitely a huge gap in the market, as I mentioned earlier. And I think I basically made this kind of really bad Venn diagram. Perhaps I should make an animation or something instead, showing why I think there's an issue here. So the people that have animation skills and the people that have science knowledge are very far away parts. There is some overlap there that I put, but the bottom statement pretty much says how I feel about it. So usually if you see a high quality animation out there, it's probably inaccurate. It's probably because it came mostly from this left part, where someone is a visual effects artist and they're really great, really awesome visual pro about that, but not necessarily have the science knowledge to do the fact checking and everything. And they probably sacrifice the science accuracy for visual appeal, stuff like that. And conversely, accurate animations that you see are not usually visually appealing. You could look in old university websites at GIFs that exist, and you'll see it tells you as a scientist looking at that, think, oh wow, that's really great. I like that a lot. It's telling me everything I know, but you can't show that to the public so easily. But there is some hope, because if you're a scientist that does any kind of programming, I do believe that there is a huge overlap in this area. So if you have animators have a lot of programming skills, scientists, at least in physics, I guess chemistry and biology probably have some programming skills too. And I think there's room for overlap. And when I make animations, I am using programming knowledge to do it. And I'm hands down, I'm terrible at art. I really am. I always have been, but I kind of like design and that kind of thing. I've always enjoyed making figures for papers. And for my thesis, I spent way too long making fancy figures for that no one's ever seen. And so if you're interested in that kind of thing, I think animation is just around the corner, really. I'll only briefly talk about kind of tools and how you actually animate, because I still consider myself like a low amateur on this stuff. I'm just scraping by. I don't even want to share any code that I made because it's terrible looking, a lot of it. It does the job though, so that's okay. But yeah, so if you do like making figures and presentations and programming, then you do already have the kind of skills required to do animations for science. But personally, I use Adobe After Effects, but there are other things like Adobe Animate and Adobe Character Animator. I don't know how to use those two. I tried Adobe Animate at first and was not successful in doing anything. And then I moved over to After Effects, which is the industry standard animation software. It does a hell of a lot of work, actually. It's really good. It's kind of a Microsoft Office of animation, I guess. But yeah, it's expensive, hundreds of dollars a year subscription if you're a student or university. But if you already have Photoshop and Illustrator, and actually I've been using Illustrator for figures since 2011. And so actually, with my own money, I've been paying for this subscription since 2011. So that's one of the reasons I thought, wow, I'm spending so much money on this Creative Cloud Adobe suite with all these animation programs I'm not even using. I'm just using Photoshop and Illustrator occasionally. And so, yeah, that's why I went into doing that. But there's lots of online tutorials and courses and help for this. I didn't do any courses myself, self-taught, but I think it was easier for me because I knew Photoshop and Illustrator quite well at the beginning. But I think I probably would have saved hundreds of hours if I would have done a course at the very start, but I had no idea how long I would be doing this for. So I recommend maybe some course like a LinkedIn course or something like that. Blender is another option. It's free. I downloaded it but not used it because I'm kind of lazy, so I'll just keep using After Effects because it works. But I know people that are using Blender very well, such as Professor Elizabeth Tasker at JAXA, one of my colleagues. And I think it has less functionality than After Effects, but I'm sure that you could do almost everything you need in Blender that you can do in After Effects. Python, I think Python is really good for bringing diagrams to life. I've not made any animations in that, but if you have a figure, if it's kind of a simple thing, I think Python would be really good for that. I want to talk a little about Twitter as a powerful tool. Now, Twitter has got 145 million users that log on every day, and the US and Japan are actually number 1 and 2 by quite a long shot for active users, which is surprising. I didn't realize Japan was so high. I thought the UK would be second or something. But yeah, these are just some things that I've learned that make posts successful on there. So videos are more engaging than images by, this is kind of a guesstimate, but about 10 times more. You get people clicking and looking at it 10 times more than an image because they want to know what happens next. Images, similar kind of thing. Well, I mean, when you're scrolling, you kind of pause an image. You've got to think about it like, what would make me stop scrolling? And usually I'm just as shallow as everyone else, and I'm scrolling, and I'm like, I don't know. If there's an image, oh, it's shiny, I'll click it. Basically, that's how simple I am. And so, yeah, people very rarely follow links. So I basically, unless it's a link to further information, I don't even bother, and nobody clicks them. Very, very, very few people read the thread's second post. It's infuriating, actually. So now I try and condense everything down into the first post, because the amount of times I've made a thread which is 3 or 4 posts long, I'm just venting now, but the amount of times I made a thread, and then I've had replies saying, oh, what about this? And I say, read the thread, because it's in the thread. They didn't click it. Yeah, so that's something to keep in mind. It's rewarding, but some things like that are frustrating. I don't know how Twitter can fix that. But yeah, videos and images, keep it the maximum resolution that's possible on the platform. So yeah, 16 by 9 is actually this resolution, or square, because when people are scrolling, these are 2 formats. I think actually only 16 by 9 is exactly the same. When you're scrolling through, it's exactly the same when you click it. Whereas some images people post are odd size, so you don't see the full image as you're scrolling, and little things like that can make a big difference. Hashtags don't work, really. They just don't do anything. They actually interrupt people's reading flow, in my opinion. This is how X works, is a good way to introduce anything as well. It actually, sometimes I've spent half an hour writing the text of a single tweet, and I think it's rewarding to do. It's kind of a nice little challenge. I call it wordsmithing, and I think it's important. But as I said before, journalists are looking at Twitter too, and they might write stories about your thing if it's successful, really, really successful. And there's lots of other things. But yeah, anytime I post anything about Earth, I get flat earthers. Anything about climate, I get climate deniers. Pretty much any topic like that. Yeah, the best thing to do is ignore, for sure. These are my final thoughts, but sorry if this is a bit of a word salad. There's so many areas I wanted to attack with this, but yeah, it does seem like a very time-efficient way of sharing science to do these animations, but and they don't just end on social media. They last somewhere else, on people's computers everywhere, and they keep using them again and again in schools for their courses, and they'll be used in courses for years. Social media, kind of different. It's a good way to boost these things, to get them out into the world. And I think it reaches people without any considerations for where they live, or if people are busy and not everyone could travel, especially during COVID-19 times. And actually, it's very difficult to explain some things with text alone, or even just a conversation like this. I did a public outreach thing last year, and I ended up repeatedly getting my phone out to show an animation to explain something. It was actually really good at getting rid of issues with the language barrier, actually, because I can't speak Japanese. But actually, through an animation, maybe about several times in one evening, I managed to explain the topic by it's kind of like a silent movie in that sense. So it does kind of transcend some barriers like that. And Twitter, I think, is super powerful for this. I haven't had as much success with other platforms like Instagram, as I said. And it does seem to me that there is a massive gap, a massive like a treasure trove of things to focus on regarding science topics. There's probably I've got like 1,000 animation ideas for my field alone. But yeah, I think if you're interested, it's a really good gig, and there's a bit of investment at first, and I recommend doing a course or something if you're interested. But yeah, I would like to see more science animations out there for other topics. And with that, I will thank you for listening.